Hi all. In this video we're going to look at maybe the relationship between function notation. We're going to look at maybe scatter plots and maybe also talk about what's going on with the solution to an equation. Okay, this is some of the material that we covered in section 1.4. Okay. So, with that said, let's jump in to what we're seeing. Okay, so one thing we learned about in class today was the two kinds of equations that we might run into in this class. Okay, there are two kinds of equations that you run into. One of the sets of equations might be an equation in two variables, I should say. An equation in two variables, and one of those equations might be written as y equal f of x, where f of x is some sort of formula, involving the variable x. Okay, so for example, we might have that y is equal to 2x plus 1. Okay, there were other kinds of formulas involving two variables that might have been of the form, say, x plus 2y equal to 4. All right, and so this equation should look different. This equation right here should look different than the one that has been solved for y, because in the blue equation here, notice that the x's and y's are on one side of the equation with each other. It is possible to solve the blue equation as a function of x by solving for y, and that would be done by moving the x to one side of the equation, subtracting, and then maybe dividing everything by 2, right? And now we have solved for y in terms of x. If you would like to do a little bit of simplification, 4 minus x over 2 is the same thing as 4 over 2 minus x divided by 2. And another way you could write that is 2 minus 1/2 of x. If you feel more comfortable writing the x first, you can put negative 1/2 x plus 2. And now we can see that these equations look somewhat similar to each other, right? So the equation that we were originally given can be rearranged into a form that looks like y is equal to mx plus b, which is a special equation for the equation of a line. Okay. Now we can see, for example, that once you have a formula, one can put those formulas into Desmos. One can put y is equal to 2 times x plus 1, and we can see that that first function, let's call it red, this one up here, looks like a line, okay? And one can find some solutions to this equation, right? So we'll remember some of the terminology we had in class, that a solution to this equation is a value of x and y for which the equation is true, for which that equation in pink is satisfied. So you'll notice that, for example, when x is equal to 0 and y is equal to 1, this is a solution. X is equal to 0, y is equal to 1, because if you put in 1 for y and then 0 for x, you'll notice that 1 does in fact come out equal to 1. So that's a true statement. And because that statement is true, we are saying that x is equal to 0, y is equal to 1 is a solution to this equation right here. What does it mean to be a solution? You'll notice that to be a solution means that that if you were to put x and then the formula 2 times x plus 1 as a y value, right? Then when you put in 0, you get 1 for that y value, and the solution shows up there as a dot on the formula, on the equation of the line itself. So every time a solution is just one of the values that lies directly on the graph of this formula, right? The graph of this formula is the equation of the line. If you pick any other random point, like say 2, 2, right, you can see here that this point 2, 2 does not lie on the line. It's not lying on the line, and therefore 2, 2 is not a solution to this equation. Right? So we can say that 2, 2, x is equal to 2, y is equal to 2 is not a solution to y is equal to 2x plus 1, because if y is equal to 2 and x is equal to 2, 2 does not in fact come out to equal 4 plus 1, which is 5. So that's why we know that this point 2, 2 is not a solution, because the solution, what would be a solution, is 2, 5, that red dot right there. That is the solution. 2, 2 is not. Okay. There was another line that we found, right? That was the line -1/2 x plus 2, right? So if we put that equation in, y is equal to, -1/2 times x plus 2, right? We can see that this line is a little bit different, right? We can call this the blue line, given by the blue formula over here, right? And if you want to find a couple solutions to that equation, right, you can do the same thing. One can insert a table of values, right? One can call it the x, and then the y value is given by copy and paste that formula in. So I think maybe we can see a solution right here. We can see on the graph maybe 0, 2 should be a solution. The reason that is because if you put 0 into the blue function, the y value comes out to be 0 plus 2, which is equal to 2. So there's a solution. And one can find other solutions like 1, 1.5, right? There's another solution to the equation. And at 2, I think we can inspect the blue function and see right here, 2, 1 should also be a solution. And if you put 2 into the table of values for this function, when you put in 2, you'll get -1/2 times 2, which is -1. -1 plus 2 is +1. So that's where this 1 is coming from. And that's why there are 3 dots, 3 solutions shown to that blue equation. All right. So there we have two different equations given, and one can rearrange them so that they are both functions of x. And what I mean by a function of x, we say y equal f of x is the form of a formula in two variables that represents y as a function of x, right? And this is the notation. So if you have an equation like x squared plus y equal to 4, it is possible to take this equation and solve it for y, in this case 4 minus x squared. If you prefer to put the x squared first, you can write that as -x squared plus 4, and y is equal to -x squared plus 4. If we were to look at some solutions to that equation, we can see that when x is equal to 0, y is equal to 4, and when x is equal to 1, we'll get y is equal to -1 squared plus 4, otherwise known as -1 plus 4, which is equal to 3. So we have two solutions to that equation, And we can look at what makes this formula in black different than the ones we did a second ago. One can either put in Desmos x, the equation x squared plus y equal to 4. That is one way to write it. Or one can write the same equation, y is equal to negative x squared plus 4. And we can see that both of these functions are the same. The graph of the function is the same. So here is the black function, right? And if we create a table of values for it with the little plus sign, let's create a table of values for x, and the y value is found by copying and pasting the formula, negative x squared plus 4. We'll make the solutions black here, the black dots, so we can see that when x was equal to 0, y equals 4 was a solution, so 0, 4 was a solution to that equation. And so too, when you put in 1, we get a y value of 3, which is what we were seeing over here. So there were two solutions to this equation. Okay, so that's enough of this video, and we'll see some more videos pop up as we move along in the course.